Hello and welcome back to another Algebra 1 video. Today we'll be starting Chapter 3, which is Inequalities. We'll begin today with lessons 3.1 to 3.3. The very first one is writing and graphing inequalities. Now for this lesson, we're going to have an introduction to inequalities and how to write and graph them. The very first thing that we want to learn is the different symbols. So there are 4 symbols that you have to know for this chapter. It's going to be less than or greater than, which are the probably the ones that you're most familiar with. And then we have 2 new ones, which is less than or equal to, and then greater than or equal to. You'll know that they are less than or equal to or greater than or equal to if you see this line underneath the symbol. Today, we're going to be learning how to write inequalities from sentences. So let's go ahead and look at some key phrases. Of course, one of the key phrases is the name of the symbol itself. So for example, less than. We also have is fewer than. So these are the 2 key phrases you want to look for whenever you're going to write a less than sign. As for greater than, you're also going to have is greater than, or you'll also have is more than. And for less than or equal to, you're going to have less than or equal to. You can also have at most or no more than. So if something is less than or equal to a certain value, it can be at most that value, or it could be no more than that value. For greater than or equal to, you'll have greater than or equal to. You'll also have is at least or is no less than. So when you have a value that is greater than or equal to another value, it can be at least that value or no less than that value. So what I recommend is that you note this down in your notebook or on a paper and memorize them so that you'll be able to easily identify what symbol you'll be using in different situations. Let's look at this very first example. We have a number W minus 3.5 is less than or equal to -2. We're going to write this sentence as an inequality. So the very first thing you want to do is identify which parts of the sentence you're going to be using in your inequality. And this is also the time you identify what inequality symbol you're using. So we have W minus 3.5. I'm assuming that this is going to be on the left side of our inequality symbol, and then look for your keywords. In this case, we have less than or equal to. Less than or equal to would represent the less than or equal to symbol. So you now know that that's the symbol you'll be using. And you can see here that less than or equal to is set to -2. So you know that -2 is going to be your value that your inequality is set to, or in this case, the value on the right. So let's go ahead and set this up. W minus 3.5 will just look like this, and that will represent the left side of our inequality. Now you can go ahead and write down your symbol, which as we identified is less than or equal to, and then finally set your inequality to whatever value you are given, which is -2, and that will be your value on the right side of the inequality symbol. Now, this is how your inequality is going to look like. Let's look at another example. We have a number B is fewer than 30.4. Write this sentence as an inequality. So we have a number B, and then now let's go ahead and look at what inequality symbol it is. We can see here that we have fewer than. That is one of our key phrases. It actually represents our less than symbol. So now we know that B is less than, whatever value we have here, in this case, 30.4. So B is less than 30.4. As an inequality, you're just going to write B, then write your less than sign, and then 30.4. And there's your sentence represented as an inequality. Now we have twice a number k is at least negative 0.7. We're going to write the sentence as an inequality. So we have a number k, twice a number k in this case. So we know that we're going to have twice of this number k. So that means that we're going to multiply it by 2. So that will be 2k, 2 times k is at least. Now this is one of our key phrases. If you look at our chart, at least falls under greater than or equal to. And then we have negative 0.7. So we know that 2 times k is at least or greater than or equal to negative 7. So let's go ahead and write 2k. So we have our variable k. Since it's twice the number k, we have a 2k here. Then write your inequality symbol and set it to whatever value you have here. So we have here at least negative 0.7. So this inequality is going to be set to negative 0.7. Here's another situation. We have tell whether negative 4 is a solution of each inequality. Show why or why not. Whenever we're asked to tell whether a value is a solution of an inequality, all you have to do is plug that value into the unknown variable. So in this case, x, you're just going to go ahead and plug in negative 4 for x. That will look like this. And you have negative 4 plus 8 is less than negative 3. Go ahead and simplify that by adding negative 4 plus 8. That would just be 4 is less than negative 3. And you can see here that now you just have to rule out whether the statement is true. Is 4 less than negative 3? No, it isn't. So you can go ahead and say that it is not true and that 4 is not, or negative 4 is not a solution of the inequality. Do the same for negative 4.5 times x is greater than negative 21. Go ahead and plug in negative 4 for x. You're given negative 4.5 times negative 4 is greater than negative 21. If you multiply negative 4.5 by negative 4, you know that the negatives will cancel out and you'll get a positive number. So you get 18 is greater than negative 21. And we know that any positive number is greater than a negative number. So this statement is true. And we know that negative 4 is a solution of the following inequality. Now that you've become familiar with all the inequality symbols and how to write them, let's go ahead and look at how to graph them. So for example, we have x is less than negative 1. The first step you want to take is to draw a number line. You're going to go ahead and label 0 and then the number where your arrow starts. So for example, here's my number line. I'll go ahead and label 0 and then the number where my arrow starts, in this case, negative 1. So that's how my number line is going to look like. Second step is going to put a circle on the number. So you're going to plot a point at the number. It's either going to be open or solid. So when we say solid, it's going to be closed. So an open circle, for example, would just look like this, or you'd have a colored in circle that would look like this. The difference is in the inequality symbol. It will be open if you have less than or greater than, or solid if you have less than or equal to, or greater than or equal to. The way I know if it's solid or not is to always look for this line underneath the symbol. That's the way I remember it, but you can just memorize it as is if you like. So I'll go ahead and put a circle on the number. In this case, we have less than. There's no line underneath the symbol, so we know that it's an open circle at -1. Now, your very last step is to draw your solution graph line. You're going to draw it in the same direction as the inequality, but there are certain conditions that you have to meet before you do this. You have to make sure that the x is on the left of the inequality. So you can see here that in this example, x is on the left of the less than or equal to. However, if it were -1 is less than x, you wouldn't be able to draw your graph line in the same direction. You will have to flip this. You can see here that the open area is pointing towards x. So if you were to rewrite this with the variable on the left side, it would be x is greater than -1. You can't simply just switch the two values like this. It can't be x is less than -1. You have to make sure that you are still accounting for how your inequality works. So this would be completely different statement than this inequality. So -1 is less than x, but in this case, if you just switch the two values around, x would be now less than -1. So make sure you're still representing the accurate inequality, which would be x is greater than -1. However, in most of our examples for this lesson, our variable is going to be on the left. So in this case, go ahead and draw in the same direction as the inequality symbol is pointing. We can see here that it's pointing to the left. So go ahead and draw your line to the left. Here's another example. We have x is greater than -2. We're going to go ahead and first draw our number line. I went ahead and did that down below. And now we can go ahead and plot either a closed or open circle. So the difference between these two is that an open or closed circle is going to represent whether or not a number is included in the solution set. So for example, x is greater than -2. An open circle is used when a number is not a solution. So this indicates that all your numbers have to be greater than -2. They can't equal -2. So when you're plotting your point, you go ahead and put an open circle because -2 isn't considered a solution. However, if you have x is greater than or equal to -2, you would have a closed circle because it is a solution of these, it is a part of a solution set. So x can both equal to greater than -2, but it can also equal to -2. So you have greater than or equal to, and that will use a closed circle because a closed circle is used when a number is a solution. However, in this case, we can see here that we have x is just greater than to -2. So we'll go ahead and use a closed circle, plot my closed circle at -2, and now identify whether your variable is on the left of the inequality. X is on the left, so we can go ahead and write our graph line in the same direction as the symbol, which in this case is pointing to the right. So this is how your graph is going to look like. Here's another example. We have x is greater than or equal to -2. So go ahead and first draw your number line. I have mine drawn below. And now go ahead and plot your point. Now you can see here that you have greater than or equal to. We have the line under the symbol, so we know that it is going to be closed circle. So go ahead and draw a closed circle at -2. And now go ahead and draw your line. Make sure that your variable is on the left side. In this case, it is. So now you can go ahead and draw your line in the direction of the inequality symbol, which is to the right. Okay, now we're going to graph the solution of v is less than or equal to square root of 36. Now we haven't worked too much with square roots, and because of that, this is a pretty simple problem to evaluate. The square root of 36 would just be 6. The way you're thinking of this is you're thinking of a 2 inside of the square root. So what times itself 2 times would equal to 36? That, of course, would be 6 times 6, which would equal to 36. Think of your perfect squares, such as 1, 4, 25, 16, those types of things. So our simplified expression would be v is less than or equal to 6. We can't plot a square root, so make sure that you're simplifying your inequality to this. Now that you have your inequality simplified, you can go ahead and plot either an open or closed circle at 6. In this case, it's going to be closed since we have a line underneath the symbol. So our closed circle will go at 6. And now you can go ahead and draw your line. The variable is on the left of the inequality. So you can go in the general direction of your inequality symbol, which is left. Okay, now we have graph the solution of g is greater than 1.4. First, go ahead and draw your number line. Here's mine. And now you can go ahead and graph either an open or closed circle at 1.4. In this case, it's going to be open since we don't have a line underneath our inequality symbol. And now you can go ahead and graph 1.4. 1.4 is a decimal, so try to estimate as best you can. I indicated the 0.5 mark, so 1.4 would just be a little bit before 1.5. And now draw your line. G is on the left, so I can go ahead and follow the direction of the inequality, which is pointing to the right. Here's a real-life application problem. We have for your birthday, you want to invite some friends to join you at the movies. Movie tickets cost $8 each. You can spend no more than $35. Write an inequality to represent this situation. Now, this is exactly the same as we were doing with writing an inequality from a sentence. However, this time we're given a real life situation. So first, go ahead and identify what you're going to be writing. So movie tickets cost $8 each. And then you can spend no more than, this is going to be your inequality symbol, no more than $35. We're going to write our inequality now. So go ahead and use a random variable to represent however many tickets you're going to buy. In this case, I'll go ahead and use T, and we know that tickets will cost $8. So that would be 8 times however many tickets you're going to get. So that would be 8T. And then you would have no more than, as we know, represents less than or equal to. So we can spend no more than our given value, which is $35. So here's how your inequality is going to look like. 8T is less than or equal to $35. We're going to go ahead and move on to lesson 3.2. Now we're going to be covering addition property of inequalities. If you recall from chapter 1, I introduced a bunch of different properties that related to inverse operations to solve simple equations. This is the exact same thing, except now we're going to be working with inequalities. Let's go ahead and take a look at the addition property of inequalities. In words, if you add the same number to each side of an inequality, the inequality will remain true. Now this is almost the exact same as the addition property that we learned in inverse operations of chapter 1. So I'm going to go ahead and show you an example in numbers just to demonstrate this. So say, for example, that you have the inequality 13 is less than 25, but let's say you wanted to add 2 to both sides. Now 13 plus 2 would be 15. Bring down your inequality symbol, and then 25 plus 2 would be 27. 15 is still less than 27, so you know that this inequality still remains true. The same goes algebraically. In this case, we're going to go ahead and try to isolate our x in our inequality. Almost the same concept as equations. Our main goal is to isolate x on one side of our inequality. So if you're doing x minus 3 is greater than negative 10, you're going to go ahead and cancel out the minus 3 by adding 3 to both sides. Negative 3 and positive 3 here will cancel. And you're left with negative 10 plus 3. That gives you x is greater than negative 7, and that is true. Now we have the subtraction property of inequality. This is the same, almost the same gist of the addition property of inequality. However, now we're doing subtraction. So in words, if you subtract the same number from each side of an inequality, the inequality remains true. So negative 3 is less than 1. Let's just say, for example, I wanted to subtract 5 from both sides. Negative 3 minus 5 would be negative 8, and 1 minus 5 would be negative 4. You see that if you subtract the same number from both sides, it would still be a true inequality. Negative 8 is still less than negative 4. And algebraically, if you wanted to isolate your x in your inequality, if you have addition, do inverse operations of subtraction to cancel out 7. And if you do that, you're left with x is greater than negative 27. Okay, we're going to solve for x and graph. We have x minus 6 is greater than negative 10. Now, if you'd like, you can almost think of this inequality symbol as an equal sign. And now it kind of looks like a simple equation where you're just canceling out your subtraction to isolate x. So do inverse operations by adding 6 to both sides. Now you have x. Bring down your greater than symbol, and negative 10 plus 6 will be negative 4. So now that your inequality is, or your x has been isolated, your inequality is now solved for x, and now you can go ahead and draw a number line to graph. So we have x is greater than negative 4, greater than, there's no line underneath the symbol, so this is an open point. Graph an open point at negative 4, and make sure that your variable is on the left side of the inequality. In this case, it is, so draw your line in the same direction as your symbol, which is to the right. You can go ahead and try these problems. Go ahead and solve them, and then graph them. Pause the video and unpause when you're ready. The first one, we have b minus 2 is greater than or equal to negative 9. I'm going to go ahead and first solve this. I'm going to cancel out this negative 2 or minus 2 by adding 2 to both sides. These 2's cancel, and you're left with b is greater than or equal to negative 7. So now that you have your b isolated, go ahead and plot this. So we have a greater than or equal to, so we know that our circle is going to be closed at negative 7. And then you can go ahead and draw your line. We can see here that our variable is on the left of the inequality. So draw your line in the same direction as the inequality symbol. For m minus 3.8 is less than 5, It's the same procedure as the previous one. Undo subtraction by adding 3.8 to both sides. M will be less than 0.8, and then 5 plus 3 would be 8.8. So now that you have your M isolated, you can go ahead and draw your number line. And then I'm going to plot 8.8. That's a decimal, so it'll be really close to 9. Less than does not have a line underneath the symbol, so we know that that's an open point. And then our variable is on the left, so follow the same direction as your inequality, which is to the left. For 1/4 is less than or equal to y minus 1/4, go ahead and add 1/4 to both sides. 1/4 cancels, and these have a common denominator, so no need to find one. So that gives you 2/4 is less than or equal to y. Now you can go ahead and graph this. 2/4 can actually just reduce into 1/2. So go ahead and plot 1/2 with a closed circle. Now you can draw your line. However, notice that your variable is not on the left side of the inequality. And able to draw your line, you have to have your variable on the left side. So you're going to have to rewrite this to have y on the left side of the inequality symbol. We can see here that the open area of the inequality symbol is facing towards y. So this indicates that y is greater than or equal to 2/4. This is still the same thing. It still remains true. Make sure that you're not just inverting the values. So make sure you're not doing like y is less than or equal to 2/4. Even though it's the same sign, this is no longer the same inequality. You have to make sure you're accurately representing the values. So make sure to look at what side is less than and what side is greater than. In this case, the less than is pointing towards 2/4 and the greater than is pointing towards y. So I'm going to go ahead and plot 2/4 or 1/2 with a closed circle, since we have a greater than or equal to sign with a line. And then go ahead and draw your line. Now that we've rearranged the equation or the inequality so that the variable is on the left, go ahead and draw in the same direction as your sign, which is to the right. Now we're going to solve for x and graph for this equation. We have -8 is greater than 1.4 plus x. We're going to first undo any addition by subtracting 1.4 from both sides. 1.4 cancels, and -8 minus 1.4 will give us -9.4. We have -9.4 is greater than x. Now, before we graph, I like to make sure that the variable is on the left side. In this case, it isn't, so rearrange this. We can see here that the less than area of the inequality symbol is pointing to the x, and -9.4 is the greater than, so x, and then have the pointy side of the inequality facing x, and then -9.4. This is how your inequality should be written to be graphed. And now draw your number line. Graph -9.4 with an open circle, since we have less than. No line under the symbol, so open. And -9.4, that's about 9.5 near there. Just try your best to estimate. And then now that your variable is on the left side, draw the line in the same direction as your inequality, which will look like this. Here's another monitoring progress slide. Go ahead and try these three on your own. Pause the video and unpause when you're ready. So we have k plus 5 is greater than or equal to -3. Here's my graph. First, I'm going to go ahead and subtract 5 from both sides since I'm trying to isolate k. That gives you k is greater than or equal to -8. So go ahead and graph -8 with a closed circle since this is greater than or equal to. And once you've done that, you can go ahead and draw your line in the same direction as the symbol since k is on the left, and that's how your graph will look like. Let's look at number 2. We have p plus 0.7 is greater than -2.3. First, go ahead and subtract 0.7 from both sides to isolate p. Whenever you are subtracting two negative numbers, you're really just adding them to get a negative sum. So that would be 3.0. And now that you have your inequality, draw your number line, open circle at -3. My graph is going by 0.5, so this would be 0.5, and all these bolded tick marks would be 1, 2, and 3. And now, since your variable is on the left side, draw your line in the same general direction as your inequality symbol, which is to the right. Now we have 5, 6 is less than or equal to z plus 2/3. To isolate z, subtract 2/3 from both sides. Now you have 5, 6 minus 2/3. However, you need to find a common denominator. I'm going to use 6, so 3 times 2. And then 2 times 2, that would give you 5, 6 minus 4, 6. And that would give you 1/6 is less than or equal to z. Now you can go ahead and rewrite this with the variable on the left. So a general rule to follow whenever you're trying to draw the variable on the left side of the inequality and you're trying to switch it is to also switch your inequality symbol around. So instead of less than or equal to would be greater than or equal to 1/6. So once you switch it, your inequality will still remain true. If you don't, then you might get the wrong solution. So now that you have your inequality of z is greater than or equal to 1/6, go ahead and draw your number line, plot a closed circle at approximately 1/6, and then draw your line in the same direction as the inequality symbol, since our inequality now has the variable on the left. Here is a real-life application problem for us to try. We're given that on a train, carry-on bags can weigh no more than 50 pounds. Your bag weighs 24.8 pounds. Write and solve an inequality that represents the amount of weight you can add to your bag. First, let's look at the information that we're given and identify any useful numbers or values that we can use to write our inequality. Our purpose is to find the weight that we can add to your bag, and we know that our bag already weighs 24.8 pounds. Our inequality should be set to the weight limit, which would be no more than 50 pounds. Looking at no more than, we can identify that this is a key phrase that represents the inequality symbol of less than or equal to. We also know that our weight limit would be 50, so our inequality should be set to 50. We're trying to look for the amount of weight we can add to our bag. So since our bag weighs 24.8 pounds, the unknown value of the amount we can add can be represented by the variable W plus the weight that we already have, 24.8. So our final inequality will look like this. The amount of weight we can add plus the weight we already have, 24.8, can be no more than 50 pounds. Now that we have our inequality set up, go ahead and solve for W by doing inverse operations. Subtract 24.8 from both sides, and 24.8 cancels. You're left with W is less than or equal to 25.2. This is your final inequality. So the amount of what you can add to your bag can be less than or equal to 25.2. Here is another two problems that we can do. We're going to write and solve an inequality that represents the value of x. So we're given two shapes here. The first one is the perimeter is less than 20 meters. Now we know that perimeter equals to the sum of all these sides added together. So perimeter would equal to side A plus side B plus side C, and that just refers to all three sides. And perimeter should be less than 20, so perimeter P would be less than 20 as represented in this inequality. However, now let's go ahead and set it up with the values we're given. So add all three sides. That would be x plus 8 plus 5 would be less than 20. And now that you have your inequality set up, go ahead and solve it for x. So 8 plus 5 would be 13. So you're left with x plus 13 is less than 20. And now you can isolate x by subtracting 13 from both sides, and you're left with x is less than 7. So your x value right here for this side length can be less than 7, and the perimeter will equal to less than 20. So for example, if you were to add 8 plus 5, and then your x value were to be 6, that would give you 19. And 19 is still less than 20, so you can see that it checks out. Let's go ahead and do the second one. We're given that the perimeter is greater than 18 feet. So P should be greater than 18. We'll go ahead and carry out the same procedure by first adding all these sides together and then setting it to greater than 18. So that would be the expression x minus 2 plus 5 plus 3 times 3. The reason I did 3 times 3 is that you can see here that you have 3 side lengths that measure 3. You can also do 3 plus 3 plus 3, but I just wanted to shorten the process. So if you do that, this can simplify into x plus 12. That would be because 3 times 3 would be 9. You have 5 plus 19 equals to 14, but you have the minus 2 of x minus 2, and that would give you 12. So you're left with x plus 12 is greater than 18. And now you can go ahead and subtract 12 from both sides to isolate x, and you're given that x is greater than 6. So in order for the perimeter to be greater than 18 feet, your x value should be greater than 6. That is the end of today's lesson. As always, information regarding tutoring, lesson requests, and additional practice will all be linked down below in the description box. Thank you so much for watching, and I hope to see you on the next lesson.